First of all, good afternoon, everyone. Thanks everyone for joining our panel discussion today. I'm really excited about this. I know this is something that we've been trying to get together for a while now. So it's great to finally see everyone. Before we start the session, I wanted to provide a few reminders on some housekeeping items. So first of all, there's a link to a survey and a certificate of completion for PDHs on the HUVA homepage. So please make sure you download that to get your PDHs. You're just gonna need to keep that for your record. It has the agenda as well and tells you how many PDHs you can earn for the whole conference. We also want to encourage attendees to enter a raffle to win the $100 Amazon gift card. There's a link to enter on the raffle on the HUVA homepage. It's only $5 per ticket, and all proceeds benefit the ITS Carolina Scholarship Fund. And we plan to announce a winner at the end of the final session. Also, for the sake of everyone, we please ask everyone to keep your cameras off and keep yourself muted. This is also going to help with bandwidth. This session is also going to be recorded. So in case you want to see the session later, or if you can only join from part of it, we'll provide a link as well. There's also going to be a networking event later today, starting at 4:30 p.m. So please make sure to check the agenda and try to attend. I know there are a lot of fun activities. So, you know, it's not the same as being in person, but we'll try to make it as fun as possible. And John reminded me earlier that if you prefer, you can actually join directly to the Zoom meeting in case you just join on the HUVA, directly on HUVA, and he just added a link in there if you want to join. Just make sure that if you go to that Zoom meeting, you close the HUVA meeting, because if not, you might have some issues with audio. So with further ado, I want to welcome everyone again to the Smart Mobility panel. My name is Kenneth Smith, and I work with Kinley Horn, and I'm joined with John Horner, who's going to be our admin for today. I'm very excited to have everyone here today and such a great group of panelists. Just to give you some perspective on the idea for today, just to have some open discussions on what smart mobility means and share some of the stories from different backgrounds. Our panel, we have people that work in DOT, in a municipality city environment, university research, and private sector. So as you can see, we're trying to get different perspectives of a topic that touches a lot of people here in the call. For this panel, we have each of the panelists first do a quick presentation on their experience with smart mobility and what they're working for. And after this, we're gonna open the Q&A. If you wanna participate on the Q&A, we have a couple of ways. You can actually ask a question on the Q&A chat box, or if you wanna talk, and we encourage that as well, you can just raise your hand on Zoom and we'll make sure that you can ask your question directly. So to get us started, I'm gonna be introducing all of the different panelists, and then we go ahead with some of their presentations. So the first person that I'm going to present is Julie White. So Julie White is the North Carolina Department of Transportation Deputy Secretary for Multimodal Transportation. In this role, Julie oversees the rail, public transportation, aviation, ferry, and bicycle and pedestrian divisions, including 800 employees and $570 million a year in state or federal funds. Julie has over 2 decades of public service in state and local government. She was awarded the WTS Women in Transportation Community Advocate Award, the NCDOT Road Gang Award, and the Triangle Business Journal 40 Under 40 Award. Julie earned a Master's of Public Administration from NC State and is a graduate of the Leadership North Carolina program and the North Carolina Institute of Political Leadership. Our second panelist is Binu Abraham. Binu is a senior analyst at the Sacramento Area Council of Governments. She's currently the project manager for the 6-county region Metropolitan Transportation Plan. She also has a master's in transportation engineering with 20 years of experience in transportation, half of it on the private consulting side and the other half in the public sector. She aims to bridge the gap between engineering and planning work with a focus on data analysis and forecasting, transportation policies, and planning for ITS and emerging technologies. As part of her tenure at SACOG, Binu delivered a Smart Region Sacramento plan, a regional ITS plan and architecture that brought together 6 counties and 22 cities within that region. Our third panelist is going to be Thomas Zajkowski. I'm sorry if I butcher the name. Try to say it the best way I could. Thomas is a North Carolina AirTAP Program Coordinator at the Institute for Transportation Education and Research at North Carolina State University. The North Carolina Airport Technical Assistance Program is a joint effort of ITRI, the NCDOT Division of Aviation, and the North Carolina Airports Association to support the state's public and private sector airport professionals. Through educational offerings, informational resources, and related assistance, North Carolina AirTAP helps North Carolina airports improve the safety, quality, and efficiency of their operations and increase the use of new aviation materials and technology. The program also helps airports staff build a community network for exchanging best practices. Tom is also the co-PI for Aerial Experimentation Research Platform for Advanced Wireless, AirPO, one of the 3 platforms funded by the National Science Foundation to form a nationwide effort to explore avenues for improving wireless communication. This is also the nation's first aerial wireless experimentation platform spanning 5G technologies and beyond. Previously, Tom was employed at the United States Forest Service Remote Sensing Application Center in Salt Lake City as a remote sensing specialist and pilot. He supported numerous remote sensing resources management and wildfire data collection projects from 1999 to 2013, working with cooperators from NASA, NOAA, Department of Interior, Department of Defense, state emergency management agencies, and universities. He also holds an FAWA Commercial Pilot Certificate and Part 107 Remote Pilot Certificate. Next, we have Katy Salamati. Dr. Salamati is a transportation subject matter expert at SAS and is responsible for providing solutions to help transportation agencies make better informed decisions in solving safety and mobility challenges. Dr. Salamati has worked with numerous DOTs across the United States, local transportation agencies, federal government, and international organizations to understand the current and emerging issues in transportation data needs and identify proper solutions to meet those needs, including advanced mobility initiatives such as connected autonomous vehicles and unmanned aerial systems. She's also an adjunct faculty of civil engineering at NC State University, where she teaches graduate level courses in transportation engineering, including highway safety, transportation planning, and traffic optimization. She has worked on numerous research grants from the National Academy of Science of Engineering, National Science Foundation, and National Health Institute, and is a co-author of several NCHRP reports and FHWA reports. She also has a PhD in transportation engineering from NCSU and an MBA with focus on entrepreneurship and technology commercialization from NCSU. And lastly but not least, we also have Hardi Desai. She's currently working as a senior associate machine learning developer at AI Center of Excellence at SAS Institute. She has previously worked with Conduent Labs, previously Xerox Research Center, as a data scientist. She's an experienced computer vision industrial researcher, having successfully built deployable deep learning models for person and vehicle detection. She completed her master's in electrical engineering from NC State in 2019 with a specialization on machine learning. So now, without further ado, and because I know you don't really want to hear that much from me, but actually from our panelists, we're going to start with some of the presentations. So Julie, if you want to get us started to talk a little bit more about what you've been doing.
Sure, I'd be happy to. I appreciate the invitation to be with y'all today and be talking about what we're doing in the area of smart mobility at the DOT, because it's a really exciting time to be at the DOT and having the opportunity to work in this space. So I want to start by sharing the creation of a new unit that we formed called the Integrated Mobility Division. So we had, prior to 2019, a division of public transportation and a separate division of bicycle and pedestrian. And I think of it, or I refer to it as, there was the day the birds landed in Raleigh. Our building is in downtown Raleigh, and we sit at windows that face the outside along the streets of downtown. And the day the birds landed, those little scooters were zipping all back and forth across our windows. I was watching engineers' faces as they just wondered, what is this? Some are in the street, some are on the sidewalk. Where did they go? Where do they belong? Are they safe? What are they? And who at the DOT should I ask about them? And so what we know is mobility is changing incredibly rapidly. Mobility as a service, micro-mobility, micro-transit, first and last mile connections, complete trip planning. And as all these things are changing, our organization has to change as well. So we took the public transportation division and the bike and pedestrian division, and we merged them But we didn't just put 2 divisions under one roof. We really created something new called the Integrated Mobility Division. So the creation of that division is to reflect the power of mobility to impact communities and our commitment at the DOT to help communities develop the tools they need to support economic development. They are focused on community vibrancy in our cities across the state. And so what role does smart mobility and the things that we can do at the DOT to encourage it, what role do we play in that space? And also recognizing in this unit the importance of sustainability and connections to land use in a way that we haven't been able to do before. Our focus on mobility and alignment of our division has fostered a sense of innovation, allowing us to work on creative and transformative projects. And our role in these projects is to pilot them, to try some new things in the smart mobility space, to seek out funding opportunities, help administer the projects, observe and capture best practices and lessons learned, and share findings broadly so that we can take a successful pilot and roll it statewide. So one example of this piloting we've done is that we brought the first fully autonomous shuttle to the state. We call her the Cassie. She is the Connected Autonomous Shuttle Supporting Innovation, or CASI, and she's a pilot program. The goal of the program is to work with small microtransit and understand how does it interface with our infrastructure? How does it interface with the other technologies we're working with in the DOT? How does it work, its suitability as a first and last mile solution? How does it help those with limited mobility move around their communities? And how does it work in a rural community? Because of course, a lot of these things are being tested in urban spaces, but half of our state still lives in rural spaces. The pilot project was also designed to inform rulemaking decisions, to learn what changes we need to make to our infrastructure, and to introduce such new technology to the public. Our CASI project has a Gen 3 autonomous shuttle manufactured by EasyMile. It was deployed as a demo in January 2020 at our Transportation Summit. And then we did a deployment along a fixed route on the North Carolina State University Centennial Campus. And our next deployment coming up this spring is going to be at the Wright Brothers National Memorial. We're really excited about this one because, again, that conversation around being in rural spaces. If you have ever been to the Wright Brothers Memorial, what you know is you park and then you walk quite a distance to the memorial. And so again, folks with limited mobility, this will be really key. And in COVID, because families tend to visit the Wright Brothers in pods, because she's a small shuttle, we can move families in these small pods in a COVID safe manner. One of the interesting things we found when testing at the Wright Brothers is she uses LiDAR and radar to place herself in the space, and that's pinging off things in the vertical space. So because it's the place where the Wright Brothers flew, you can imagine you flew there because there aren't vertical things. So, that was one of our first takeaways. Okay, rural spaces don't have the same amount of vertical construction. So we're having to simulate that with signage that we're putting up. One of the big takeaways we learned when bringing the CASI here was about the regulatory hurdles for American-made shuttles. So NHTSA has an exemption process to allow foreign-made shuttles to deploy in the US on public roads, but they do not have an exemption for domestically made shuttles. Another thing we learned was our own DMV standards were designed for vehicles with human operators. They made references to things like mirrors. Well, of course, CASI doesn't have rear view mirrors because there isn't a human, right? She has cameras, but our DMV had to adhere to the law as it's written. So we actually had to put mirrors in to accommodate that. So it really helped us inform what kind of regulatory changes that we need to make in some of our laws. Another example of where we're doing some really interesting piloting in smart mobility is our City of Wilson RIDE program. The City of Wilson was operating a fixed route transit system, so a bus circulator in its more dense urban space. It's a city of about 50,000. So what they found was it wasn't working well for their community. It didn't typically go where folks needed to go. Like if your major job center is manufacturing, that doesn't exist in the urban core, that exists on the outskirts of town. It was an hour-long headway. It was not frequent enough or going to the right places. And so they came to us, the city came to us and said, we'd like to look at shutting down our fixed route system and putting that money into microtransit. And so we worked with them to figure out how to do that within the FTA rules and regs. We helped identify some additional federal funding in a discretionary grant that we helped them put together that grant application, and they won, so they could expand the amount of time they can offer the service. And what's really amazing about this is since they launched, they have served more people in COVID than they served on their fixed route pre-COVID. What we find as we move to microtransit is there's an underlying demand that exists when you provide people a more functional system. So we're really excited by what we're finding with this pilot. The pilot program was done in partnership with a company called VIA. And when you're working with a town the size of Wilson, you really need to provide a turnkey solution. And so VIA was able to do that. They provided the vehicles, the drivers, the app. So it was very turnkey for this mid-sized city that needed that help. And so what we're seeing are 7-minute wait times. We are seeing it cost less per person to move people. We are seeing that discovered additional underlying demand. And then when we stood up our COVID initiative to help people get trips to vaccines, it was really easy when you already have that app-based technology to add a little checkbox to say, I need this ride to get to a vaccine, and the system can prioritize it. So it really allows you to be nimble and quick when being responsive. It's already won an AASHTO award for innovation, and we're already talking to other parts of the state about standing up similar initiatives. A couple other initiatives in this space, our Mobility for All pilot in Northeastern North Carolina. We pursued a discretionary grant and won it with the ICPTA system in the Northeast. This is going to allow them to get the technology to link transit trip scheduling with the NC Cares 360 platform to improve healthcare access. So much of transit is linked to access to healthcare. And so you need to merge your technology platforms to allow when somebody books a doctor visit to have that transit trip scheduling brought right alongside it. It will also include the testing of other technologies like contactless fare payment and real-time bus tracking. And these are just a couple of the ways that we are working with this new unit, the Integrated Mobility Division, to pilot these new technologies, smart mobility options, see how they work, and if we're successful, bring them further out statewide.
Great, thank you so much. It's really interesting. I'm probably going to get a lot of questions about that as well. So our next panelist that's going to introduce herself, Binu, do you mind talking a little bit about your work and what you've been doing?
Well, thank you for inviting me. It's really good. It's nice to see everybody. And I really want to say thank you, Julie, for going first, because I want to just say ditto and be done. Everything she said about what she was doing at the state DOT are things that we are doing here too. As you heard, that I work at the Sacramento Area Council of Government. So we are more planning focused. We are a COG, a Council of Government, and an MPO for our region, which is 6 counties, 22 cities, and 11 transit agencies. So our focus has always been transportation and sustainable communities and land use and reducing the greenhouse gas emissions following the state and federal requirements on emissions and all those things. But when the smart mobility market emerged, it provided us a nexus between sustainable communities and some of the long-term things that we were always trying to address through our long-range plan, which is reducing the congestion, improving the safety, improving the reliability of travel, providing modes of transportation other than just cars, improving our transit. How do we connect everything? And the focus became change from point A to point B travel to how we can take a community and make it more vibrant, like it be self-sufficient. So everything that we were doing in our long-range plan, we just found that there was this gap that could easily be filled by going the smart mobility route. So we added that. We, like Julie mentioned, we started a department or a team that was innovative mobility, which took into account how does ITS, how does TDM, travel demand management, and how can we fill that gap in the space that will help all our cities and counties do better. So we are not people who do implementation, even though we help, but we found that as an MPO, our biggest help is providing funding for people who wants to try new things. And our motto is, let's pilot some things. If we fail, let's fail fast and learn from it. And our biggest challenge is that we are a MPO that has 80% rural communities and 20% urban, and we have somewhere in between, we have suburban communities too. But 80% of our people live in the urban communities. We have to find some way to bridging, some strategies to bridge the urban, rural, and suburban communities. So that was our biggest challenge. So when I took on this project of the Smart Reach in Sacramento, my biggest goal was to, how can we develop strategies that will work so that we can be equitable to all our community needs, all our transit, all our pedestrian, all our bikes and scooters and cars and everybody else. How can we be fair to all? What can we do to bridge and come up with some strategies so that the transition between one city to one county to another one would be seamless? So that was our goal. So with that, we started something called Civic Lab, which is a place where we bring together all our local agencies, member agencies, and Caltrans, which is our state DOT, everybody together to focus on one problem. And we provide funding and we provide a venue for them to share different ideas and come up with a solution and then to try it. So we also found that the best way we can help our region is by trying to find as much funding as we possibly can to help everybody do what they need to do, because everybody's need is different. And we are not trying to dictate what each agency should do, whether we should do this or that, but we are trying to say that let's have some equity in how we deal with all modes of transportation, all regions, whether you are rural and your needs are different from your urban area, whatever it is. And we also focus on more on the pricing or the mileage base, which is now the trend that I'm seeing. How do we account for that? How do we implement something at a large scale, like in Sacramento region? So these are the kind of questions that we deal with. And to me, a lot of the questions the answers to that became easier once we nailed down on smart mobility. I'm not saying we nailed it down, but to have something there that we can use for solving a lot of issues is, in relation to adding capacity projects, it's cheaper and faster.
Great, thank you so much for sharing. Up next, Thomas, you want to talk a little bit about what you've been doing?
Okay, thank you. Okay, got my mic, everything on right now. Thanks for having me. You know, as we go along, I'm sure we're gonna all echo some of the same things or that previous people have talked before us. And I'm coming at it from a university perspective. So I'm from, part of the group I'm with is the Institute of Transportation Research and Education. I'm going to be talking more aviation things, but of course, a lot of my colleagues work with Julie and DOT on like the pedestrians, the bike peds, and transit and that. But I'm coming at it from our aviation side, and we have a number of different projects going on with both the state and the FAA. Some of the research we are doing with the FAA is like we are looking at urban air mobility. So one of the things that we're looking at are safety standards, aircraft certification, the impact on the market, the feasibility, making sure that there is an actual economic is economically viable to be growing. So we're going to look at, there's a lot of things out there about urban mobility, air mobility, but there are challenges out there. These include how we're going to build the aircraft, how you're going to power the aircraft, how they go into the airspace they are operating in. You're already even, and as well as ground vehicles. Julie mentioned a couple things there that it's like, there's already a system that you are bringing these vehicles into, and you have to be able to meld within that. And another thing is to integrate into that, into those things. It's like, I think one of the things we're going to look at with urban mobility, air mobility, sea mobility, whatever it is, it has to integrate with the system, and the users are going to see that it's a seamless system, not just like it's a standalone thing. What is this value added I am bringing into this system? So there's a lot of things that you need to look at. We're looking at moving from manned cargo to unmanned cargo. That's another form of mobility, and looking at how you're going to be integrating into the NAS, how that's going to work. And then one of the other projects I'm working on is the North Carolina Airport Technical Assistance Program. That is an existing system, and they're interested in, those airports are interested in seeing how they would integrate into air mobility and ground mobility. How are you bringing people to their airports? Can we make it so that when you show up, you're going to have more of a seamless trip through security and get on your plane? It's not going to be I get there and I get to wait in line. I'm going to kind of walk through everything, as it were. So there's those sorts of things. And then, the final thing that I am working on is with the Aero Experimentation Research Platform for Advanced Wireless. And we are building a research platform through National Science Foundation funding to test 5G technology. And we're going to start out with unmanned aircraft and figure out how we can, how wireless communication can facilitate these things. How, these are the nuts and bolts on how I'm going to make everything work. That's from the aircraft's command and control to the user's experience while they're in there, while they're flying along. How can they be on a Zoom call? Can they be doing work while they're there, or even just watching a show? So those are the kind of things we are hoping to be up here in the midsummer, and we will start hosting experiments with a number of different companies on that.
Great, thank you. What about Katy and Hardi?
Yes, thank you. Let me share my screen. I guess we come with slides. Can you all see this?
Yeah, I can see it now.
Okay, great. So thank you for this opportunity. I'm joined with my colleague Hardi here to talk about using the technology, especially in this case, computer vision technologies for traffic cameras, and what use cases are available, and how we can really utilize this infrastructure that is already available to many DOTs and cities to be able to use it more efficiently and more effectively with the traffic operations. Really, the traffic analysis using the computer vision is all about being able to increase the efficiency of our TMC operations with the many cameras that are available, increasing many cities are now dealing with a wall of cameras, maybe at some point hundreds and thousands of cameras. And so how we can utilize the technology, which is relatively new. It's not very new, as the computer vision has been around for a very long time, but how we can utilize the algorithms to better use it for detecting congestion, detecting traffic violations, or using it for more of a speed estimations and real-time tracking of the vehicles, or more of a batch processing, replace it with or use it instead of the sensors for vehicle classifications or vehicle count tracking. So we've worked on several projects using computer vision, applying computer vision technologies into traffic cameras, and using a variety of capabilities, SaaS primarily, but then SaaS is an open platform, so we can very well integrate with open source platforms and use other technologies, open source technologies such as Python for processing, such as CVAT for video annotation, and other open source capabilities. And I'll hand it over to my colleague Hardi to talk about the technical aspects of the particular project that we worked on.
Yeah, thank you, Katy. So here I will give you a brief overview about our entire pipeline. On a high level, it consists of 2 steps. Mainly, it is the offline model training using SAS VIA and SAS VDMML. And secondly, we have the online video scoring using the SAS ESP, which as we call it as SAS Event Stream Processing. Now going back to the offline model training. So as you see in this flow chart, these are the steps which are taken by us when we are trying to generate a computer vision based or a machine learning based model which is able to probably detect the vehicles. This first step consists of collecting the video feed from the traffic cameras. Next, we have the calibration of the cameras. And here from the calibration, what we mean is that we try to adjust the camera angle, the focus, how much, what angle we want, so that we are collecting the right data. We are able to view the vehicles correctly, the zoom, pan, tilt, all of that matters at this stage. Next, we have the scraping of the historic data. So as we know, this computer vision, deep learning, machine learning based algorithms are data hungry, and we require large amounts of data which is used for training so that we can so that the algorithm can perform in real time. So this is about collecting the huge amounts of data. And as we have variations in our environment, especially with respect to considering North Carolina, we have a quite, our weather is quite changing. Like we can have sunny days, we can have days where it rains. So we need to capture all those data points in our training data so that our model learns to perform in all the situations. Next, we have the pre-processing and the augmentation of data. This consists of steps like whether we want to resize the image, whether we want to change the image aspect ratio, and augmentation is again consisting of steps like rotating, flipping in case we want to increase the data even more, and whether they would fit into that scenario or not. Next, once we have our data ready, it is important that we annotate the video frames. Like each frame which has been collected, it is super important for a human to go over it, to annotate it. And here, as Katy has already mentioned, we have used CVAT based annotation tool, where we are trying to see what kind of vehicle it is, whether it's a passenger vehicle, whether it's a truck, whether it's a light duty, heavy duty truck. Next, we come to the training of the vehicle detection model. This is basically the machine learning based model which we are developing using SAS deep learning capabilities. And here we have to basically tune the hyperparameters so that our model performs well. And lastly, once we have the training data, we split it into the validation. We keep on validating how well the model is performing during this training process. And once we are happy with our results, where we have an accuracy like our required accuracy, which would typically go around up in 90s, we generate and store all the trained weights of the model so that it could be done for the online video scoring. And this is stored in an A-store format. So the entire training process, we get the final model, which is stored in A-store. Moving to the online video scoring, we import the A-store into the SAS ESP, which is the event stream processing, and which does the processing in real time. So if the video feed is coming in real time and we have the trained model, which is stored in an A-store file, we can then do the real-time processing of detecting the vehicles, classifying it, and all the other use cases, as Katy has already mentioned. As I had mentioned about pre-processing in the training step, it is very important that we pre-process the live video footage in the same format. Like if I have resized the images during the training, it is super important I do that because the model has learned to perform well only on the data what it was trained. So there is a pre-processing step. Next comes the scoring, where we are actually generating the results. Once we have generated the results, or the machine learning model has been spitting out the output, like what kind of vehicle it is, and it has been continuously detecting it, it is important that we do post-processing. And here by post-processing, what I mention or want to refer to is filtering, and also the models predict the classes based on certain confidence. So how confident the model is, it could be sometimes the model is just 60% confident. So we need to apply all the post-processing steps so as to, make sure that our outputs and the results are as per required. All this pipeline is done using SAS ESP and is real time. Lastly, we have the two analytical reporting, where we would be providing the statistical analysis of all the observations which could be done using the SAS visual analytics, and the ongoing data can be managed. This can be managed in both terms. If the model is drifting over a period of time, we have the SAS model manager, which can help us to whether we need certain kind of retraining or where the model is failing. Also, we can manage the entire data. Moving forward, here is a quick video where we are displaying the vehicle detection as well as tracking. I would like to mention here that our algorithms are pretty sensitive to vehicles around the road. So we have focused on detection and tracking inside the blue box, as you could see. And if you would have observed by now, the algorithms are pretty accurately trying to detect as well as count the number of vehicles. This is basically a traffic junction, and we would like to thank the town of Katy for helping us collect this data and so that we could analyze here. Next, this is a quick demo about the speed estimation. As you know, this was a traffic junction, so the vehicle 5 and 6 were probably stationary, and that's the reason we see a lower speed here. However, these vehicles which are moving at a relatively faster speed than previous one, they would have probably encountered a green traffic signal. And this is an ongoing project, so we are still working towards getting more accurate and better results. Next, I would like to hand it over to Katy for.
Thank you. Thank you, Hardi. I wanted to really elaborate on, the actual really being able, the capability to be able to operationalize this kind of technology for essentially using it as an advanced mobility technique for the future of transportation, or even for the current state of the transportation, to be able to detect traffic anomalies, being able to detect speed, and being able to do that in real time. One of the other capabilities is, as Hardi mentioned, is really applying this into real-time capabilities. So as you see here, we have the capability to capture the live feed of the traffic cameras, and in real time being able to detect the type of the vehicle, whether they're a passenger car, a heavy duty, light duty, or medium duty truck, and in real time showing where that location is and how the counts are changing. And then also, in addition to what Hardi showed us, really being able to use that as a dashboard for better decisioning and better better decision making, and reducing the amount of the time that an actual human being needs to be able to look at these cameras and make a decision. There are also other use cases here that I briefly wanted to talk about, since we are talking about multimodal and pedestrians as well. We've applied the same object detection technology into, for example, in this case, being able to detect the same object that are pedestrians, but they're all moving at a different, but some of them are moving at a different speed. So a pedestrian that is walking versus a pedestrian that is actually on a skateboard and moving at a different speed. Again, the capability to be able to distinguish between these, being able to get a count of these objects, and being able to distinguish what is moving faster than what is moving slower. Another use case that we also worked on, and this one in particular is focused on geofencing. And as Hardi mentioned before, the geofencing is really around identifying where the particular objects of interest are. In this use case, we have the car, we have the bus, we have the pedestrian, we have the motorcycle, but then they are in different locations. And are they supposed to be? For example, are we expecting to see a motorcycle on the sidewalk or not? Identifying and associating the object of interest into the geofence, with the geofence location, the particular geofence location that they would belong to. And as I mentioned, and Hardi also alluded to, is more of a being able to train the models offline and then apply it in real time using our event stream processing engine into the with the actual algorithms that are available to us. I also wanted to focus on, the challenges that we had, because with every technology and every project that we work on, there are various challenges, and some of them, we found ways to overcome that. So there are particular things that we need to focus on when we're working on these traffic cameras and computer vision projects. They seem to be very, very interesting, but they also require particular capabilities or particular aspects that needs to be paid attention to. For example, the traffic cameras. For applying a computer vision technology to that, they require to be a fixed and reliable traffic camera view with no panning or zooming, or if they move around, we just have to make sure that we train the algorithms based on that. The speed estimation rely on high resolution cameras, having high resolution frame per seconds. They require a particular reference measure in the video, so then for example, a length of a lane marking is about 10 feet, or the distance between them is about 30 feet or so. So having an actual point of reference in real world. And also there are also challenges with detecting the objects and vehicles at night, or foggy or snowy, and other weather conditions. So these are the factors that needs to be paid attention to, and the models needs to be trained based on that. And then there are different camera views, or all of these different conditions that would require different training models. There's, as Hardi mentioned, there's the post-processing that needs to happen for geofencing and filtering the data. And then also, as Hardi mentioned, the models require resizing and all of that. So these are all these factors that needs to be considered when we're working on a particular computer vision project. And we've been able to essentially find ways to overcome some of these challenges. And then, there are also challenges with working directly with the traffic cameras. There's one thing to record the videos and then do analyze it and applying a computer vision to it. But then there's another thing if you want to do this in real time. And for this particular use case, we worked with, for one of these use cases, we worked with the Access firmware. And, the format of the traffic cameras, their proprietary format of videos. videos that are provided by the traffic camera, the vendor. There's the issue with connecting the videos and how we're getting that video in real time, where we are storing it in real time. For example, in this use case, we use the Microsoft Azure storage. So how we're connecting the protocol that we're connecting to the traffic camera, to the camera firmware, and then storing the videos, and then working around connecting the camera to local drive and having it being connected to a simulated drive share, local share, and then sending that information back to Azure. So they are the nitty-gritty technical aspects of really being able to bring an actual computer vision project into life. There is one thing of training the algorithms and having the algorithms work on historical camera, but there's also another thing to actually being able to connect to a camera in real time and absorb that information and applying the models in real time. And with that, I hand it over back to Kenneth, and happy to answer any questions.
Great, thank you so much. Yeah, so as mentioned before, thank you everyone for presenting. This definitely gives everyone attending some background on some of the projects that you've been working on. Now we want to open it for the Q&A, and I actually see that there's already one question in there, so we can go ahead and answer that one. Thanks, Ron, for sending it. So the first question that we have, so transportation has over the years used the latest technologies to improve systems. What makes these projects that are being presented as being smart, and are these smart characteristics the same whether the project or system is in a small, mid-sized, or large metro area? Open it to any of the panelists that want to answer.
I'll jump in because I love when we start to think about what these words mean in an urban context versus a rural context. So as I said before, in North Carolina, about half of our population lives in rural communities. And so having worked for cities, predominantly big cities in North Carolina for my previous job for 10 years, what struck me was the Raleighs and Charlottes in our state can figure these things out themselves. They have the resources, they have the workforce, they have the expertise. But if we don't step in and figure out what these things mean in a rural context, we'll be leaving parts of our state further and further behind than they already are. So I do think there's a contextualness to the conversation. So for example, if you're using transit in an urban space in North Carolina, they likely already have the sensors on the buses, so you can see where the bus is. They have the little signs in the bus stop that tells you how many minutes till your bus arrives. They've made that trip, that smart mobility trip, really frictionless. They probably have jump bike opportunities at the bus stop. So they figured all that out. In a rural community, smart mobility might be like what we're doing in Wilson. It's saying that on-demand transit, for example, in a rural community runs, call it about on average $22 a ride for a county to provide it. They don't have a lot of technology solutions, so you call 24 to 48 hours in advance to book your ride to the doctor. By bringing technology and apps into that space, you're making that ride, booking that ride and getting that ride easier and more. I often think of smart mobility as just being more human-centric, right? So much of mobility in the past has been designed around how we make a car go faster, right? It's like we're congestion, based in our metrics, and we're about how do I cut trip time for a vehicle? How much faster can I push a vehicle through a thoroughfare? Whereas I think smart mobility is about where does the human need to go and how do I make it easy and how do I address all parts of that trip? So in the rural space, by having the technology, that human can decide not 48 hours in advance they need a ride to the doctor, but 7 minutes in advance they need a ride to the doctor. They can do it, through the app. They can have the credit card tied to it. So we're just making it easier and meeting them where they are. So I love thinking about what does smart mobility mean in a 25,000 person town or a 5,000 person town versus in a Raleigh or Charlotte.
A simple way that I look at smart versus intelligent or smart versus whether what we are doing qualifies as smart or just ideas, is that intelligence is by itself a complete thing. Like if you do a vehicle detection, that is an intelligent system. But if you connect it to something or you use something else to tell a different story on how it is going to like make a conclusion out of it or use it for something better, then it becomes smart. That's how I look at it. If you look at the example that Katy mentioned in her presentation, she had detection of pedestrians or vehicles of different mobility options. But then she mentioned about how she used geofencing to talk about where they are, where that location is, and then use it for improving the traffic in some other way. To me, that is smart. Individual pieces of her project are intelligent operations. When you put them all together and connect it in a way that you tell a story, that becomes smart.
Yeah, and I think in my opinion, like I might be super technical here, but anything which is basically reducing the human efforts, because if I see a road video footage with vehicles going by, I don't think I can sit and count like which class, how many vehicles went, but based on my algorithms and stuff, the system is automatically doing it. So for me, that is smart because I don't think I would want a human labor or someone to do such kind of a tedious job. However, it is really important for the traffic management to know at, say, a signal junction, what kind of traffic it is. If it is high, do they need to increase the green light timing or the red light timing? So that's what makes things smart for me.
Yeah, and these are all great points, and I just wanted to add that I think based on what Hardi and Binu said, it's more of a improving the decision making. I would say even what Julie mentioned, the example that Julie brought up. If I'm going to make a trip, do I need to prep in advance 47 minutes in advance or 7 minutes in advance? It's all about being able to use the technology, use the tools that are available to us to improve the decision making, faster decision making, more accurate decision making, and also, what we always wanted to say here at SAS, more of a predictive, being able to predict what's going to happen and essentially prepare a better response for that. And as Hardi mentioned, just reducing the human efforts in all of these processes.
Well, going last, I don't have much else to add, but a lot of it is like, when it's all the vehicles and all the systems working together with each other, that, that allows the frictionless thing, that allows you to have 7 minutes beforehand to make your trip. That's what makes these things smart.
Sorry, that's great. And one of the things that I've heard from a lot of you is a lot of also like collaboration and partnerships, and that's actually like another question that we got here is related to were there any public-private partnerships that were instrumental? And I would like to elaborate further because I know a lot of us, we understand some of the partnerships that need to happen for these, but sometimes there are some groups that you didn't expect them at the beginning of the project that ended up being an integral piece. So if you could elaborate on any of these partnerships.
I can take a stab at it and then others can add on. So I think in this field is driven by private organizations and companies and vendors more than the public. So this is one field where if we have to make a change on the road, we need private-public partnership. And I think that's why PPP became a big deal over the last couple of years. The automobiles, the different options, the scooters, anything that you talk about, micro-mobility, all these are, even Uber and Lyft, and all that is driven by private agencies that want to make a change in our society. But the only way they can do that is by getting permission or permit, which is where the public agencies come into play. I think the biggest roadblock for innovation is also public agency. And I get that because we have a lot of liability issues and we have a lot of people that we need to answer to. Private entities can just make something and they can test it, they can put it on the road and they can do it. But if anything happens, we need to make sure, I would say public agencies are grounded by fear more than innovation, and private entities go with innovation and wanting to change, do something different and be the leaders in the agencies. So the only way these two can coexist if we sit down and have a ton of conversation. And even then, I own it. I'm from a public agency. I own it. I say that we are the reason a lot of innovation is not taking place. And it's not because we don't want it, but we have a lot of fear. We are always driven by fear. There is the politicians, there is our need for people's approval, there is the need to justify how we use the tax money, all these things. But that's where the conversation happens. We had private partnership, we are still having it. We work with a lot of auto industry, like Audi is testing on our roads right now to get the information, the signal information, so that they can perfect their technology for the AVCV. We work with our municipal utility division. We work with air districts. We work with a lot of industries and a lot of new vendors who bring in new technology, especially in the managed lane pricing area. Because pricing is another new area that we have to test, and nobody knows how to do it. Mileage-based fees, we don't know how it is. We don't even have permission to do it, but we don't want to be limited by, let's wait until we get permission and then try something. That's too late. So we want to drive that conversation, but I 100% agree. That is a slow, painful process. If there is a way to make it faster, I would love to hear it.
I think that's really well said. I was making a note, thinking about government as being so risk adverse. I think that is something we are always afraid to fail, right? Because failure in government is not rewarded. It is not accepted. And so I think I'm really proud of the DOT for being willing to take some risk. As a leader in the organization, your organization has to have your back and say, yeah, we want you to go be innovative, and we recognize some of those innovations will fail, and that's okay. We're told fail quickly. Let's not spend a lot of time and money failing. But that was the whole idea, our pitch of having an entire branch in the integrated mobility division dedicated to innovations and pilots. To say to the organization, we're going to take some risk, but we're going to do it in a little project. We're going to do it small, we're going to do it cautious, we're going to identify the risk, we're going to mitigate the risk, and then you're going to bless us, and either we're going to fail quickly or we're going to do something really cool and then bring it forward. So I think that's just so well said about thinking about government and how we can be the inhibitors of innovation if we don't have a culture to allow for failure to happen.
I think I really agree with both of you. And since I come from a private background, unlike both of you, I remember working with few public agencies where, in spite of my models having accuracy of 92%, we used to get a reject that, no, that's not acceptable. We needed more than 95. We needed around 96, 97. And sometimes I really like to thank you guys, because when you guys push us off our limits, we are actually able to deliver, because somewhere we want to deliver it. So I think it works both ways. Innovation is also coming when you push it to the level that, no, this is what is required. So
yeah, exactly. I completely agree. And I wanted to add to that, coming from actually working at both public and private agencies. I used to work at ITRI at NC State. One of the things that I realized that sometimes we have the technology and we have the answer, but we're really looking for our customers, the public agencies, to tell us what exactly their problem is, so then we can help them solve it. You know, we have a toolbox of various different technologies and tools at our disposal, but knowing exactly how this technology can be applied to add value, to make the job of the government and public agencies easier, that's where, you know, this collaboration comes into play. And sometimes, you know, the subject matter experts are really, you know, the public agencies, the ones that they're the true ones that are, you know, in day-to-day operations. They're using these tools, they're applying these tools to improve their operations. And so having a more you know, open conversations and more access to these end users will help us with improving the technologies that we're working on and developing.
Yeah, I agree with a lot of that. You know, some of the things, I guess, coming from the aviation background, is when you do fail is pretty spectacular. That, you know, when you look at that, you know, sometimes the FAA has recently come under fire because they did open things up and it did not work out, as in the 737 MAX. You know, where we're trying to, let's like prototype these things, let's get them out there fast, let's see how it's going to go. You know, kind of like how you can see with Elon Musk, and he's crashed what 10, 12 boosters now, but he can keep going, and that's accepted. But when we do things, when we're carrying people around like we're asking for, and when we're doing things in urban environments, you know, the level of failure that you can accept is extremely low. So that we can't just like do this fail now and fail often. We have to have a way of getting people in there and working with it. Now, you know, both for AirPod and some of the things we're looking at, and you know, NASA's doing with urban air mobility, there are companies there that are willing to put money into it, because it takes basically about $1 billion or so to get these things off the ground. So there has to be money involved. And it's not going to be coming from the federal or state or local levels. It's like we can work with them to make sure that we understand what they need, but they have to be able to deliver on that safety aspect.
Yeah, that's great. So we have another question. I also want to encourage everyone, because I've seen that some people have joined, some people have left the meeting. So if you're new here in the meeting, please make sure, if you want to ask any questions, we have the chat box. You can also raise your hand if you want to ask the question directly. So another question that we have: has COVID-19 had any impacts on your projects or on your future projects?
Oh yes, I will say that. We are AirPod. We wanted to be on some of the projects we're doing. We wanted to be started out at the beginning of the year, and we're stretched out until summer. And a lot of times it's just like we just can't get the parts. Having students, having people work together has been very difficult. You know, it's opened up some, and then we have also seen, and talking to the people who are supplying the parts and you know, designing the software for us, that's all it's not just within us, it's within all aspects down the supply chain.
So I think what COVID, absolutely what Tom said, supply chains, inability to work together, all of those things are true. But one of the things I think that was a positive as well is I think COVID showed us how essential transit is as a modal option. It showed that our grocery store workers and our pharmacy techs, this is how they get to and from work. And a city cannot function if it cannot put workers in a grocery store or in a pharmacy. And so I think we're having this new conversation that's really important about the questions of access. What does it mean from an equity consideration if you don't have access to the economies or healthcare or education? And I think these are great conversations to be having as we move more toward mobility as a service. I think we're thinking about how does transit look when it rebounds? If it rebounds, when it rebounds, how does it look different? How does mobility as a service look different? We're spending a lot of time in air quality conversations on our trains, on our buses, HVA systems. We're spending a lot of time thinking about contactless surfaces, payments, facilities. So I actually think what COVID has done is it has pushed us to be innovative quicker and faster and sooner. I think it's created some of that space to demand we be more nimble, and nimble comes from technology. And so I think it's had some really interesting positive effects as well.
To answer the question of has any of our projects been impacted? No. If anything, we had a positive outcome that for years for actually decades, we've been trying to promote work from home or telecommute to reduce our peak travel. And this has proved to be effective. And this has provided us a way of doing it, like providing the internet connection, knowing what are our gaps, knowing where we have the problem, what we need to fix. It was kind of like a pilot, but not a good pilot and too long a term of a pilot. But this has helped us understand some of the needs of our residents a little bit more.
Okay. So talking a little bit more about, we've talked also about how people are so important in your different projects and the public facing part of this. What are some of your experiences when approaching the public? It seems like there's a lot of education, there's a lot of, you need to ask them what they prefer. Just want to hear a little bit more how the reaching out to the public has worked for you, and if you had any pushbacks, because not everyone accepts new technology.
Well, so far, most of my experience has been with drones, so unmanned aircraft, and that's been up and down. When I first started years ago, during some big California firestorms, we were actually with NASA flying a very large drone. It was called the Icona. It was actually a MQ-9 Reaper, but NASA had the foresight not to call it a Reaper. And so at that time, it was like the public was like, hey, we need to work. We need to get this flying over our cities so we can stay safe. And then as the smaller drones came up, it became a whole, we never, as a community, we never communicated what we really wanted to do with these aircraft. And then it became like we're spying on everybody. We're doing all these things, nefarious things with them, instead of saying, well, no, these are the good things that can come out of this. And I think that, at least in the aviation community, for sure, but I think a lot of the other communities have looked at this. We understand that, like, urban air mobility, it cannot be seen as being just for the rich people. It has to be seen as it's an equitable situation where this is improving everybody's lives. And there's just not, like, one of the things we're really worried about is noise, is the noise that would be created by these. It's going to be less than a helicopter, but that's still pretty noisy, especially if around these vertiports and these, how are we going to manage those things, and where are you going to put those with still making it economically viable? How are we going to spread that around?
What options are you considering for making it more equitable?
Well, that's the problem that, that we have. It's like, how are you going to get the seat mile down to a point that it's not? One of the things that, when we're looking at, I was on a meeting and they're talking about a few years ago, they were coming out with what they call very light jets. And this is kind of a cautionary thing. It's like, these are much cheaper than your normal corporate jet. So we're going to have all these planes flying all over. It's going to be a renaissance of general aviation. Well, the jet still costs $1.5 million. You have to pay a pilot to fly the thing. You know, it just came down to it wasn't cheap enough for even your middle class to upper middle class person to afford to travel with. And then the people who were traveling by jets, they wanted to travel by a really big jet. So this is one of the things that we are looking at is, well, how do I make it cheap enough where it is a comparable cost to go that I can move more people around? Do I share the rides? You know, one of the things we do understand is you can't have a specialized operator and I guess that's coming back to the smart thing, is like the operator or the pilot, he or she's not necessarily they're flying the thing. The vehicle flies itself. They might be directing it where to go, and it's going to go within some parameters, but everything else is going to be integrated into a system. And that's something that we have to do, is get the specialized operators out. And, you know, that goes right through to the maintenance, recharging the batteries, those sorts of things. In aviation, it's like to work on a plane, you have to be an AMT mechanic, which are very expensive. Again, we have to bring those sorts of things out. And it comes down to, when you're developing the system, you don't put the vertiport in the poor neighborhood. You don't do the same thing that happened when all the highways went in. We started like, well, this is where the cheapest land is. Let's put it here. This is understood that we can't be doing that. It's like, if it's going to, if you're taking people to an entertainment district, that goes to the entertainment district. It doesn't transit through somebody's neighborhood.
Can I ask one more question, please?
To who?
This is considered more like a Uber for space, you know, like for air travel or something like, right? What role does FAA have in that? Are we flying high enough that FAA needs to regulate it, or?
So the FAA is involved in air travel once you get off the ground. So it's like, yes, this is part of their air. You are integrating into the NAS. One of the things they do realize is that urban air mobility, when you're in drones, like when you're flying lower to the ground, the way the air traffic controls is set up will not work for that. It is not designed to be low to the ground. It's not designed to have, like, you know, if you have hundreds or thousands of delivery drones and hundreds of these air vehicles, it's not designed to do that. The radar can't see it. The air traffic control can't deal with it. We have to design a whole new system that will integrate all of these things more or less autonomously, and all the while working with the current air aviation system.
Interesting. Anyone else wants to answer the question, how they dealt with the public side and how to reach out, or maybe some tips on educational resources?
Well, one thing that I wanted to add was more of a, working from on a public side, but dealing with some of these publicly available or personally identifiable information such as PIIs. Our clients always have this question and challenge that we can't be sharing too much information, or what we are sharing for the purpose of analytics should not be essentially invading anyone's policy or anyone's privacy. So what we do for our projects is mainly very cautious and being able to essentially have guidelines and policies in place, so the privacy of the users are not invaded, or for the purpose of analytics, everything is anonymized, so then we can't really track one particular person for the purpose of the analysis. It's more of a how the general data is showing and how the behavior, the aggregated behavior of the data points that we have, what is it that they are telling us, rather than pinpointing a particular person. For the purpose of transportation use cases, I would say. There are other purposes, for healthcare or criminal activities, or investigations that we focus on particular identities. But for the purpose of transportations, there's really no need of being able to identify one particular person, or where that vehicle is, or what that pedestrian is going, who that pedestrian is. So for in these cases, they're all very analytical methods in place, or anonymizing the data in place. So then we are working with the aggregated data, not focusing on the identity of the people.
Great.
I would totally agree to that. And like, we especially have those kind of efforts going on that side, that how can we blur the person when we are showing the footage and stuff like that, or even blur the license plate or something like that. Yeah.
Nice. So I know one of the things that we also, and in some of your presentations, you talk about some lessons learned. If you had to tell someone from an agency, organization, private sector, some tips on how to implement new technologies, now that you've been through those processes, what would you tell them? One lesson learned that you would like to share that you think it's important for everyone to know? And sorry, I know it probably requires some thinking.
So I think for us, we're thinking a lot about ownership of the data, ongoing maintenance costs, things like that. As a government agency, if we don't own the data, and we have to do like a follow-up monthly fee to maintain data and ask the private company to pull things we need from the data, I think I give a lot of thought to data ownership, maintenance, and such, to make sure you know what you're buying.
Coming from a MPO perspective, the one biggest lesson I learned, and I wish I knew that going into this, was the difference between planners and engineers and how they see the world. And I don't necessarily mean that they don't understand each other. They do. They are all very smart and intelligent people. They absolutely understand. The issue is the lens at which or through which we view the world. The operations people, which are mostly made of engineers and traffic engineers at city and county level, they have to deal with things that break, and that needs to fix right there. They are always putting out fires. The planners have a very long-term vision. They're thinking of 20 years ahead. So when somebody is coming and telling us about, okay, we need to do this because this is a problem, our infrastructure is 40 years old, it's not going to handle that. The planners don't see that. And I see a lot of that in the funding applications I receive. It's compelling cases, but the narration or the story behind that is what the planners go for, not the actual the problem itself. And usually when you have a system that is failing, which is 50 years old, you don't have a compelling story. It is like, if we don't do this, our signals are not going to work. That is a compelling reason enough for most people. But the planners are like, oh, tell me how that feels into a 20-year vision of where everybody is just flying through the air. And that's where we are lost in translation. And I feel like in every agency, whether you're a planning agency or an operations agency or an implementing agency, there needs to be a need for more influencers or champions who will take the time to explain it to the other person. And I learned it. It took me 6-7 months because I went into managing this project, which was $1 million planning study. And I had a group of 30, 40 people in the room, and we couldn't agree on anything. And I was thinking, why is it so hard? You know it is important. We have to do this. We have to reduce the greenhouse gas emission and reduce congestion. But they are telling me things that I wasn't understanding from the lens through which they are looking at. It took me 6 months to get to that point, and for them 6 months to understand that my job is to think long term. Their job is to fix what's wrong today. So that communication would have helped or helped us save 6 months of our time. I think that's the one thing I learned. That was my biggest takeaway.
Okay. Any other input?
I can say from the, at least from the, implementing the projects, and, we generally work on more of an operational projects than more of a long-term planning projects, although all those also require a lot of, analytical capabilities. But I would say from our experience, it's all about really understanding the actual problem. Sometimes we work with clients, and they have an understanding of the problem, but we really have to look at the problem from their point of view, from the lenses that they put on, and really understand down the line, how is this going to improve their operations, and how is this going to improve their bottom line. And that's when we can really find the best tool and the best methods to help them solve the problem. Sometimes we would think, or both parties, even from the beginning, we would think that a particular methodology, a particular technique would help solving this particular problem. But when we are really going further down, and as Binu mentioned, maybe like 6 months down the road, then we realize the actual underlying problem was something else. The actual challenge was something else, and we first need to fix that in order to be able to fix this. And for fixing that one, you would have used a different methodology or a different technique. So really, as somebody who will work on these projects and try to solve these challenges for our clients, we really need to look at what this problem is going to solve for them, and what it actually means for them, and how is this going to help their operation. So then we can find the best method for that.
Great. Well, so I know we also talk about organizational changes, and I know, Julie, you talk about how now you have the integrated mobility division. How has this affected? Because now we have new software, new technologies, and more data that we've ever had. So I'm guessing there have been a lot of changes in the past few years. So how has that changed your organizations? What are some changes that you're seeing, or some trends where your organizations are going forward with all of this?
I think we're spending time from an IT perspective thinking about data. So we think about, IT security, cyber security, right? Where do we keep our data? Is it all on the same platform? Where I think we haven't gotten to in government quite yet is to understand how important the data scientists are. You can't just have a lot of data, and that means you'll do something interesting, right? So you got to then add the staff component, the expertise component, to know what to do with all that data. So I see us like getting really good at the IT part of it, but I think we've got a ways to go as government to understand the data scientist part. I'll give you an example. We have a lot of data in our ferry division. So we needed to look at optimizing our schedule. And what I discovered was we had a whole bunch of Excel spreadsheets, like a whole bunch of Excel spreadsheets. And the data started with somebody with a counter, click, 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 and then they'd write it on a clipboard, with a pencil. And then that piece of paper would go into somebody else, and they would punch it in to an Excel spreadsheet. And so, you'd fat finger things, or, why you didn't run, you might type weather and the next guy might type storm. Like, so we reached out to SAS to do a project with them to say, I have all this data. Can you help me figure out how to do the science part to know how to optimize a schedule? And through that exercise, we discovered the data wasn't good, right? It was just poor data. So again, like as a government agency, we're like, yeah, we have lots of data. And then when we get the data scientists, they're like, but your data is really poor quality. And so it's not really decision-making quality data. So I think as a government agency, investing in the technology to get good data, investing in the scientists, those are the pieces I think we probably need some more work in.
Any other organizational changes happening in the different organizations?
I think I know at ITRI, one of the things, with this smart mobility is that we are seeing that we cannot be as stovepiped as we once were. It is just like the highways people have to work with pedestrian bike people, the aviation people have to work with these people, and we're seeing a lot of cross-related projects going on because we realized it's just, you cannot just like focus in on these one things, going back to your question about what I would tell people about when you start a project is not be, it's good to be, you need to be optimistic, but you shouldn't like make some grandiose claims. Like in airborne mobility, it's like, we're going to have so many of these vehicles up in the air, it's going to relieve congestion in our city. And that might not be, because the more people you take off a road, the more people realize, oh, I can go on the road because there's not as many people on the road. So it's like, be realistic as to what you're doing. But one of the things is, going in the organization, you have to look at the big picture because it doesn't, this thing does not exist. Any transportation system doesn't exist in a vacuum anymore.
Tom, you make a great point. I think when people, like with urban air mobility, when people do presentations where they show, all kinds of vehicles in the airspace like that, I watch my engineers at the DOT say, it's not going to be like the Jetsons. Listen. Yeah. And so they get very dismissive, right? And they're not wrong in that it's not going to leap to that point, right? So I feel like, to your point, we need to talk about kind of the incrementalism steps so that they recognize the future's changing, but they don't think we're spitballing or, something that's never going to happen.
Yeah, I agree with that.
So we have another question in the chat. So I think this one's directly to you, Julie. Since the availability of data is so significant, what is the next step when it is found that the data is not good? Do you start all over again, or you try to modify that data?
That's a great question. So I'll give you the ferry example for our ferry division. We have routes that are tolled and routes that are not tolled, right? So when you deal in money, you got a great audit trail. So for the tolled routes, we had pretty good data. We had ways to cross-check it. The non-tolled routes, I actually sat down to Tom's point about getting out of our stovepipes. I went to our Turnpike Authority because, of course, they have all kinds of technology around counting cars and collecting money. And they have the little sticker that goes in your front window, which is a barcode, which would enable us to, beep it, right, as a car would come through. And those are less than $1 a piece. So when I think about, what kind of technology can I invest in that's cost effective to get me better data? That's a partnership that we're looking at. And so I think it's, finding the right sized and cost technology that we need to move to, because we are really building something from scratch at this point. So, in the past, when ferry contemplated a technology solution, the non-tolled routes a few years ago, it was a multi-million-dollar solution because, technology when it first comes out is expensive. So they couldn't execute on it. Now the cost of technology is coming down, right? Getting those little things for less than $1, getting the little beepers in the handheld. These are all become much more affordable solutions. So I think it's about constantly revisiting the technology solutions and building something more effective than we had previously.
Yeah, this might go a bit off-guarded, but I think I can add a little bit here, be having experience with all this data and stuff. So a lot of time it happens that for the original problem, what the data we got is probably not, we cannot solve the problem. But when we look at the data, we might come up with some totally different analysis, and then we propose to the public agencies that, hey, your data you shared for this reason, this is not the problem statement we can solve, but we can probably get this insights from this data. And that's when the collaboration also kicks in that, oh yes, why don't we do this? So sometimes, you know, doing certain analysis, certain statistical transformations, we convert the data in some different format, and some totally new use case has probably turned out to be. So in my experience, even those kind of situations have happened. And then as the conversation starts going, we, like, as a data scientist, we try to understand, okay, what all are your problems? And we probably don't need so much data. We just need this data. So, you know, the public agencies can actually work. Oh, this is a very short requirement, the way Julie just explained that, you know, on cost effective, how can she generate all that data from scratch? And I think that's how there is a, you know, good collaboration between the technology innovation with those public agencies.
Yeah, definitely. And now that we're talking about data, and just so everyone knows, I'm very passionate about TISMO. So if you notice, we actually been pretty much all around the circle. One of the things that I want to touch also about is performance measurement. And I know, Hardi, you mentioned that, yes, sometimes even us, like on the consulting side, we try to push you in the private side a little bit on that. But I also want to hear, because I think it's also important to just understand the data and just make sure the systems are working. So are you doing any performance measurement with the new technologies that you're deploying? Just want to hear a little bit more about it.
Yeah, of course. Like there has to be, when I talk about accuracy, it's like, you know, specific to the use case, we develop different metrics. What are the key performance indices there? And then we also have, like Katy has already mentioned, we have that dashboard in real time, which is going on. And then we have the entire summary statistics so that we can see the trend over the period of time. We can even have models where we are maintaining the model health, like basically the model, the machine learning algorithm, it might perform well today because the weather was sunny and nice, but it won't perform tomorrow well because it's just rainy or snowy. So we need to keep on continuously monitoring it. And that is something we really like, it's something a very important aspect of our day-to-day life, that like, okay, it's not over that today I train the model, I get good results on my training data and even maybe validation data, but if it doesn't work well on the test side, it doesn't make sense. And like it's super important. Yeah.
What about with the implementation of any of the systems? I know for like the apps, for ridership and all of that, are you checking that data, just trying to understand a little bit better if there are any issues with a specific group of people, or are you trying to use that data in any way to just keep improving the system?
Of course, like, okay, you can go.
No,
ahead.
go ahead.
Oh, no, that's fine. That's fine. You can go ahead.
Well, yeah, so I just wanted to add that, yes, absolutely. And really, you know, the performance measures and essentially, you know, just to add to your question and combine it with what Julie mentioned, that data management and data quality for any project, any keeping track of the performance measures or monitoring the data, any of that is our key, is essentially is 80% of the job that we do. We've got to be able to work with a good quality data. We've got to be able to have the data in the particular format that we can feed into the analysis. I mean, the data should be in, for example, the digits, or you know, if you're working with the structured data versus you're working with unstructured data, such as text, how we're handling all of that. So in the process of data collection and gathering all of that, there are some methodologies that we put in place for data governance, for data quality. even extract, transform, and load the data. And then we can also set up these real-time alerts that as the data is coming in, are they good quality data or not? If you're working with real-time data, we can detect anomalies in the data. If sometimes the anomalies doesn't necessarily mean that the data is bad. Sometimes the anomaly means that there is something happening that we didn't account for. So whether we're dealing with the real-time data or the historical data, there are all these various methods that could be put into place to be able to detect what the outliers are and how we're going to treat these outliers. And then once we realize that this is a valid outlier versus this is not a valid outlier, then they could be treated differently in, as Hardi mentioned, in the model development or in the further analysis. And so, for example, some of the data that for the use case that Julie alluded to, some of these data were not necessarily really bad data. They were just representation of a much smaller let's say much smaller sample or a much smaller or particular use case, a weather situation or a ferry breaking down that would, or route being changed for a particular day, just hypothetical examples. And, they resulted in some sort of a data points that were a valid data point, but they were different from the rest of the population. And sometimes the data is just not there just because, as Julie mentioned, somebody fat fingered it or they put in the wrong information. So there are all these various methods in place to be able to detect these. And sometimes we can also apply mathematical and analytical models to really not only identify the bad data or the outliers, but also see how we can correct this data. Does that help?
The other thing, Katy, I'd add that I thought was really helpful in working with you all as the data scientists is you were able to make recommendations to us as you extracted our data from SAP and looked at how we kept it. You guys were able to say, hey, you do it by terminal. Have you thought about doing it by route instead? So getting the data scientists to help an agency think about how we collect our data so that it can be used in more ways, for the analysis, I think were some of the best recommendations that came out of that project.
Okay. Thank you.
Okay. Something just kind of tying all the different presentations on ITS Carolinas together as well. One of the presentations early this morning was about the FCC ruling. Has that made an impact in your organization? I know it changes a lot of things going into the future, maybe some of the planning that you were doing in a city or in a state. Just want to hear a little bit more. How has that changed since that ruling on November 18th? If any. Looks like that's not really affecting you. So that's great to hear. So I want to leave it open. I know it's already 3:40, so I want to make some time as well. I know we've had some questions. I want to give a chance to anyone in the audience. If they want to ask a question, if they want to raise your hand, please let us know. We've been able to talk about a lot of different topics, so I just want to make sure if anyone has anything they want to say, they can share it now. And if not, some of the other things that I just want to know about some takeaways. So wrapping up this conversation, we've talked about all these different things that we've been talking about. Implementing new technologies is not an easy thing from either side you're working on. If you had one takeaway, something that you want to tell people, recommendations on how to implement new technologies. I know we talk about like cost, how difficult it is to just try to get costs for these things in the future, or how to get better funding or better information. Any recommendations that you would have for any of the participants?
I think I'd say, I go back to what folks said earlier about like performance metrics. I really like the idea of piloting new technology. New technology can be a very expensive endeavor, and I always like to proof it first. And then, you know, if you've established what are your success metrics going to be, you've piloted it, you've invested small. I'll give you another example of one. There's a product in aviation where, so there's long been a lot of data on airports, planes at airports, right? But it's a lot of it is self-reported by the airline. So they will report to the FAA and to the airport, this is how many of our planes took off and landed at your airport. And they pay airports fees for that. And there wasn't a lot of way to check that. So some smart tech company, you know, came together and started scraping data sites, right? So they took tail numbers and they took, you know, landing information, such, and they've put all the data together, which, as I said, was all publicly available. But the technology platform that they put it on, the dashboard they put it on, is the key to the whole thing, the whole reason why this is so interesting. There are a host of reasons you might look at this now. You could use it to look at human trafficking. You could look at it to verify the data of what the companies are paying you to land. There's a host of different ways to do that. And so we're going to pilot it. We're going to invest a de minimis amount of money. We're going to try it at a couple particular airports. We're going to, we've actually got a firm that's going to evaluate it for us after a year and say, what did we learn? You know, what are our success metrics? And does the juice warrant the squeeze, right? Is the amount of money we're going to invest worth how we're going to use it? And if then we need, as a public agency, to secure more funding for that, we've got a story to tell, right? We've got, here's what we did, here's what we found, here's our metrics, and now we'd like to take something like this statewide. So I really would recommend to people with new technologies, start small, give it a bite, see if it works, proof it, and then before you invest further, you know, do that first.
Yeah, I think one of the other things is that, you know, you have to be able to like prove the investment economically. You know, again, using the airport thing, you know, airports sit there and people who don't use that form of transportation see it as a big money sink. So, you know, we're constantly having to prove that the airport gives back to the economy. You're giving us tax dollars, but we're supporting the economy through jobs, through personal income, but also the mobility that provides. There are companies there that are in your community. They're there because of that airport, because they can go somewhere really quickly.
I echo both Julie and Thomas. The only thing I would add would be managing expectations when we start on pilot should be a big deal.
Yeah.
I guess I can talk about one of our recent experiences trying to do a pilot around UTM's unmanned traffic management systems here in North Carolina, also working with multiple companies and also trying to work with you know, public agencies and DOTs. It really comes into, it's essentially, you know, even doing a pilot project is an orchestration. So you know, coming from the private side and, you know, the consulting side, we are very much interested in collaboration and very much interested in bringing all that together, and also being able to you know, reach out with our DOT agency and work with them together on really solving a problem. And I think the main key for a successful pilot is to even be able to solve a small problem and show that we can solve that small problem, and then take it further into you know, really starting from something small, meaningful but small, and then taking it into a, you know, a larger meaningful pilot and a problem. And I understand that nobody wants to be the first one who participates in this. You know, what if it fails? But it's very important to be able to have that opportunity to test different things, even it's small.
Great. I really thank you all for your time. I really enjoyed the conversations we had today, just talking a little bit of everything related to like also like the TISM processes and how everything goes back together, even on the smart mobility side. So I really hope that everyone also enjoyed and learned something new today. I would give a round of applause, but it would be a very silent round of applause. So I really appreciate everyone's time. Before we finish, I want to make sure just go back again to some of those housekeeping items. There's going to be a networking event later today starting at 4:30, so please make sure to attend that. There's also the raffle, so you can go to the homepage and sign up. And we also have the PDH form in there. So thanks, everyone. It was great seeing you all.
Thank you. Bye.
Thanks, John. Appreciate it.
You're welcome. Bye.